Okay? And so that's another area formula that we have, the area formula for a triangle in terms of its side lengths, instead of having to find like a height, too. We can just use the side lengths. So let's look at this next one here. So letter A, okay, it's already kind of set up for us here. So it asks us to find the area of each triangle to the nearest tenth. Okay? And so it's pretty clear here what information we're going to use because we're given the exact information we need to find the area, right? So again, we can use the fact that here we'll say the area is going to be 1/2 times the side length of 3.2 times the side length of 4.7 times the sine of, yes, the obtuse angle there of 142 degrees. All right? That is the exact setup right there. And if we multiply that all out, just check to make sure my calculator is in the right mode. Yes, okay. So 0.5 times 3.2 times 4.7 times sine of 142, we get our area there of approximately 4.6. And what would our units be here?
Meters.
Meters?
Right?
Yes, meters squared, exactly right, okay? When we're talking about area, it's meter by meter, so it's meters squared, square meters. That means if we, got 4 squares that were 1 meter by 1 meter, and then, a 0.6 of a meter by meter square, so another square that's 0.6 of a meter by 0.6 of a meter, you could fit them all in this little shape right there. Okay, 4.6 square meters. All right, so let's try another one here. Let's go to the next one. So B is not drawn for us, so we get to draw it ourselves. So in triangle DF, DE is 9 inches, DF is 13 inches, and D is 57 degrees. So I'll just go ahead and just draw a random triangle here. Okay, so we got D, E, F. DE is 9 inches, DF 13 inches, and angle D is 57 degrees. So again, thankfully, they gave us the exact amount of information we need to be able to find the area of this triangle. All right, and so it's just going to be area equals 1/2 times 9 times 13 times the sine of 57 degrees. Okay, the two sides and the angle, the sine of the angle between them. So 0.5 times 9 times 13 times sine 57. Boom. 49.1 about. And this will be in square inches. Right? Questions on any of that? Alright, so I'm not going to have you guys try the your turns. I think they're pretty straightforward, so we'll skip those, but go ahead out. Okay. The next little section here, Explain 2, talks about solving a right triangle, but this is awfully familiar to stuff we've already done, so I don't want to spend actually any time on this. I think you guys are going to be fine, would be fine on stuff like this. It is, solving right triangles. So it's here we want to, let's see, it says, a shelf extends perpendicularly 7 inches from a wall. You want to place a 9-inch brace under the shelf as shown to the nearest tenth of an inch. How far below the shelf will the brace be attached to the wall? So basically how long is this? So very clearly here, what could we use to solve for this third missing side? Pythagorean theorem. You got it, okay. And then also it asks us to find to the nearest degree what angle will the brace make with the shelf and with the wall. So we want to find this angle or this angle as well, okay. And again, we would find those using what? What could we use for angle A, for example? To find angle A here, what could we do? So cosine, exactly right, and cosine inverse, right? Because you have the adjacent and the hypotenuse, so it would be cosine of A equals the adjacent side 7 over the hypotenuse 9, and you just do cosine inverse of both sides to get angle A. Yep, and for B we could use sine, exactly right. So yeah, I'm not going to spend time looking at that. We already know this, but it's there in the book. What I do want to get to, though, is on to explain 3. I guess let me just go ahead and finish solving this real quick. So since we have it, so angle A would be 38.9 degrees about. Oh, it says to the nearest degree, so 39 degrees then. and you can find angle B by subtracting from 180, or, like Maria said, using sine. Okay. Well, this is where I want to get to right here, okay, and that is right triangles in the coordinate plane, solving right triangles in the coordinate plane. So, because I just want to give us some more practice with the distance formula. I feel like we don't quite have enough practice with it, and I just want to make sure we get some more practice with it. So you can use the distance formula as well as trigonometric tools to solve right triangles in the coordinate plane. Okay? So, it says to solve each triangle. Now when it says solve each triangle, that means we want to find all the sides and all the angles. Okay? And so here's our triangle here. Triangle ABC has vertices -3, 3, -3, -1, and 4, -1. And we want to find the side lengths to the nearest hundredth and the angle measures to the nearest degree. Okay? So, let's take a look here then at this one, at this triangle. And let's just find the side lengths. Well, some of the side lengths are super easy, right? For example, the length of AB, what's that going to be? What's AB? Let's go to Elizabeth. What's the length of AB there, Elizabeth? Yeah, 4, right? We can just count that. It's a nice vertical distance. All right, and then what about BC, Zishan? 7, you got it. Okay. AB and BC, the angle at B, all right, what kind of angle does that look like? That is there, let's go to, oh man, come on. Julia, what kind of angle do we have at angle B? Does it look like?
Right.
Yeah, right angle. Yeah, I mean, it's like pretty easy right there, right? So that, now we've taken care of all the super quick stuff we can just kind of like look at and get. John, what can we do to find some other missing pieces here of a right triangle?
Well, if we want to find AC, we can do Pythagorean.
Yes, exactly right. We can use Pythagorean theorem here. So if we do Pythagorean theorem, it's going to be, what is it, 4 squared plus 7 squared equals, yeah, we'll call it just x squared for the hypotenuse. Okay, you call it h squared if you want to, whatever. So let's say that's 16 plus 49 equals x squared, and that's going to be 65. Yeah. And so then square root both sides here. Okay. They said to round the lengths to the nearest hundredth, so that means we can just go ahead and type this into our calculator. We don't have to worry about like simplifying the square root. So square root of 65. Boom. 100. So 8.06 is what we'll say. Okay. Now, one thing I want to point out here, alternative to, okay, or instead of finding the hypotenuse using the Pythagorean theorem, we also could use the distance formula here, the distance formula from A to C. Okay, and you can see here that's actually what they did right here. They used the distance formula. So remember the distance formula, if I can like squeeze that in maybe like right up here. The distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, let's look at these numbers here and see what happens. That's our distance formula here. Okay, so x2, that means one of the x coordinates here. So let's see here. Let's go to so Maria. All right. If we're going to find the distance from A to C, give me one of the x coordinates of one of those points. Like so. Okay. A's x coordinate is -3, and then minus what is C's x coordinate? 4. Okay, right. And then what about the y coordinates? What's A's y coordinate? 3. And then -1. Now, if we simplify this sum, obviously they already did this here for us, but let's actually simplify this sum because it does simplify. So let's see, -3 minus 4 is -7. 3 minus -1, well, if I do minus and negatives plus positive, it becomes 4. Now, if you look here, where have we seen these two numbers? They're the sides of our triangle. Okay? In fact, the distance formula here, it is the Pythagorean theorem. All right? All we did, and when we subtract the x-coordinates, when I take one x-coordinate and subtract the other x-coordinate, I'm finding the distance between those 2 points. Yeah, I know we end up with a negative 7, but because we square it in the Pythagorean theorem, it doesn't matter whether I do this one minus this x-coordinate or this x-coordinate minus this x-coordinate. It doesn't really matter. So I'm going to end up squaring it anyway. The sign will, become positive regardless. And so we end up doing square root of 49 plus 16, which is exactly what we did right here. We added 16 and 49, and we took the square root of that sum, 65. Okay, the distance formula is the Pythagorean theorem. We end up with a square root of 65, exactly what we got, so it's 8.06. Okay, so the distance formula is just the Pythagorean theorem. All right, it's kind of like a more formulaic Pythagorean theorem. You subtract the x-coordinate, subtract the y-coordinate, square, add the sum of the squares, and then square root the answer there to get the side, hypotenuse. So that's it. All right, cool. So we got that. But now we need to find some of these missing angles here. So let's see. Let's go to Michael. How can we find a missing angle here? Like angle A on page 727. All right. How can we find angle A here? What can we do to find angle A in that right triangle? What can we use to find a missing angle in a right triangle? Yeah, tangent. So let's say tangent of angle A is going to equal what over what there, Michael? 7/4. Yeah, 7/4. Okay, and so let's see here, tangent of A, so we do inverse tangent like you said. So angle A is tan inverse of 7/4. And we get 60.255, so we'll round that down to 60, to the nearest degree. And so A is about 60 degrees, and that makes C about what then? 30, yeah. Now obviously it's not exactly 30, 60, 90, right? Because if they were exactly 30, 60, 90, what should the hypotenuse be then? Not 8.06. The hypotenuse would be what? Eight. Exactly, Sean. Yeah, exactly 8 is what it should be. So clearly we rounded these, so that's why the hypotenuse isn't exactly 8. Okay. What is the area of this triangle? What's the area of this triangle? Zishan, how can we find the area of this triangle?
7 times 4 divided by 2.
Exactly right. So let's do that. So area equals 1/2 times 7 times 4. So let's say it's going to be what? What is that? So 7 times 4 is 28, and then half of that?
That'll be
14. So the area is 14. Okay. Now let's try and use our other formula here and see if that one works too. So we think the area should be exactly 14. We have a base times the height there. So let's use our other area formula. That was the let's see here. So in this case, I'm going to run out of space, but I think I can fit it in here. Other area formula we have is 1/2 times, and let's see. Let's pick an angle here. So Mary, pick an angle. Which angle do you want to use? A, B, or C? A. All right. So if we use A, that means we're going to multiply what two sides? It's 1/2 times what two sides for the area? Yeah, BCA. So if we're going to use BCAC, that means it'll be the 30-degree angle we're going to use then. There you go. Yeah, AB and AC. Those two sides are then 60 degrees is the included angles. Yep. So we'll do 4 times 8.06. Ooh, I can fit it times sine of 60. Barely fits, but there it is. Okay, and so that means the area equals, and we just multiply that out, 0.5, and in fact it does work here, times 4 times 8.06 times sine of 60, and it's 13.96. Now our answer is a little off from what the exact answer should be, but why is that? Why is this area formula a little bit off from the exact one we got right there? Why isn't it the same? Andrew?
We rounded the 8.06.
Exactly. We created some error here by rounding that 8.06, right? It wasn't exactly 8.06, but we rounded it, so there's a little bit of error. But that's why it's close. So we can say, okay, close enough. They are the same thing. All right. Very good. Alright, let's try another one here, and then I'll give you guys like a little assignment, okay? This one's got a lot of stuff going on too. Alright. So, letter B on the next page. Triangle DEF has vertices D, -4, 3. E, 3, 4. And F, 0, 0. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. Alright, so the directions here said to plot points D, E, and F and draw triangles draw the triangle DEF. So -4, 3, 3, 4, 0, 0. And that's, oops, I forgot to label that one. That one is F. Right there. Okay. Now it looks like, according to the directions there, it says that F appears to be a right angle. To check, find the slope. So let's see here. Let's see if F really is. It looks pretty close to a right angle, doesn't it? There's a right angle on my paper. But it says here to check, we should find the slope. So let's see here. So to find the slope of DF. So let's see here. To find slopes DF's slope, they did something -3. So if we want to find the slope between D and F, what should we go in that top little box there, Shannon? What number should go in this box right here? If I want to find the slope between D and F, so these 2 points, what goes in the box there, Shannon? Do you remember? So slope formula is change in y's over the change in the x's. So here you can see that from coordinate D, we subtracted the coordinate 3. That's the 1 y coordinate. What's the matching y? What's the matching? What's not the matching? What's the y coordinate over here in F though? 0. Thank you. You're going to make this go at 150. All right. So 0 is what we put in there. And then what about in this position right here? We're going to do 0 from point F minus, and then what's the x-coordinate from here from point D there, Shannon? Yeah, -4. Okay. So we just do y2 minus y1, 0 minus 3, over x2 minus x1, 0 minus -4. Okay, so 0 minus 3 is -3. 0 minus -4, +4. Okay, which doesn't really simplify, so I'm just going to leave it as the fraction, -3/4. And then what other slope should we check here, Shannon? Besides DF, what other slope should we check to see if we do have a right angle right here? Yeah, you got it, EF. All right, so what are the y coordinates we're going to subtract on top there then, Shannon? Yeah, the y coordinates, yeah. For E and F, points E and point F. Yep, 4 and 0. So we can do 4, take away 0 if you want. And then on the bottom, oh, they did a different order. Shoot, I have to do 0 minus 4 because they already have the 3 written in there. So we'll do 0 minus 4, and then we'll do 0, take away the 3. We get -4 over -3, which simplifies to 4/3. So if the slope of EF is 4/3 and the slope of DF is -3/4, what can we say about this angle here? What do we know is going to be true? The slope of EF is 4/3, the slope of DF is -3/4. That means the angle at F there has to be what measure? Yeah, 90 degrees. What about the slopes gives that away? Opposite reciprocals. Yeah, we have to have both things. So that one's negative, one's positive, that's opposite. And then reciprocal, well, they're flipped, right? One's 3/4, one's 4/3. So yep, that tells us right away. We know, aha, 90 degrees. So this triangle happens to be 90 degrees. All right, and then the next thing says, find the side lengths using the distance formula. Woo! Okay, so let's do that. So we're going to do DE here. All right, so here's DE. Remember, distance formula is x2 minus x1, so we're going to subtract the x-coordinate. So D's x-coordinate is -4, and E's x-coordinate is 3. So we're going to do 3 minus -4. So there's the 3 minus the -4. Plus, and then we're going to subtract the y-coordinates. So again, it's E's y-coordinate is 4. Take away the y-coordinate from D, so 3. So it's 3 minus -4 plus 4 minus 3. Wow, and it has us do that all at once here. So 3 minus -4 is 7, squared is 49. I'm going to put this down here because that's going to be too much for me to keep in my head. And then 4 minus 3 is 1, squared is 1, so it's 49 plus 1, so it's the square root of 50. And they want us to simplify this then. The square root of 50, what does that simplify to in simplest radical form there? Let's see here. Yeah. Square root of 50 is the same thing as the square root of 25 times the square root of 2. Exactly right, Keegan. And so what's the square root of 25, Keegan? 5. So you get 5 square roots of 2 there. And then we can get that, we see a little squiggly equal sign. That means they want us to give us, they want the decimal. So 5 square root of 2, 7 point, and here's hundredths, so we'll say 7.07. Okay, so you guys go ahead, finish out. Find DF, find E, and we already did DE, so FE as well. So find DF and find FE. Okay, find those two lengths. Let's go ahead and finish those two out there. Let's try and find the rest of those distances. I'm going to do the same thing, too. So let's see here. DF. Okay, first one. Oh, you got these for me? Gotcha, thank you. I get that for you. Staple. Well, ideally the ones for this term, and then I remember from here on out I'm going to try to remember to collect them weekly like I wanted to in the first place. So it should be from starting at like November 2nd. So like, or that one maybe, yeah, starting there. Yep. Just your name on the front one's fine. I'll stay for the rest together. So 4 squared would be 16, 3 squared would be 9. 16 plus 9 is not quite that much. Oh, there. Good. So you see here this has a square root of the box, this does not. It's a value of what the square root of that is. Let it eat. So well, let's see here. So DF. Okay, so here's point D, here's point F. So So the x coordinates will be negative 4 minus 0.
Good.
That first one is good.
Oh, cool. I didn't take it. Sorry. Very close. Okay, that first one looks good. Actually, the second one, yeah, but the first one you guys run around. Okay, so there's the two measurements we get. DF is 5, FE is 5. So interestingly enough, we have a diagonal measurement there, but it ends up being a nice number of just plain old 5. And then this value here, we round it to be about 7.07. Now, in the next step, it asks us to find the measure of angle D, and then also find the measure of angle E. Do we need to really do any work here to find what D and E will be? What will angle D have to be here? Yeah, it's got to be 45 degrees. What kind of triangle are we dealing with here? Yeah, 45, 45, 90, exactly right. So angle D is 45, angle E is 45. This is an isosceles right triangle, and so therefore it's a 45, 45, 90. So if that's true, DE we had to round, but we actually know the exact value for DE, don't we? What must the exact value of DE be? Let's see. What is it? What would DE have to be here? 7.07 is rounded, but we can come up with the exact value. What would be down there? Yeah, 5 root 2. Well, I guess we already have that here, never mind. But that's not surprisingly, right? It's the 5 times the square root of 2. And this is x, this side's x, this side's going to be x times the square root of 2. So it's 5 square root of 2, right? I guess we could already have that there. But it shouldn't be surprising to us. All right. So there we go. So I'm going to give us a little bit of practice with that. So let's see here. Okay. So what I would like you guys to work on then is to it's going to be like strange maybe because of the nature of this. But I think I'm going to give you 3 problems. All right, but the third one might not take a little bit of time, but just require a little bit of thought.